Okay, so let's go ahead and get started here. Hopefully, you guys have had a chance to work through that starter page with all the different types of questions. I did lay it out in a pretty specific manner. There's a reason why I did that. Hopefully, most of us were able to get through the first, 4 or 5 questions up here in this section pretty quickly. I'm probably slowing down maybe a little bit after this section. I doubt too many of you guys got down to this portion with these 3 down here. Like I said, there's a reason why I did that. If we take a look at the solutions really quickly, again, I'll post this content on Google Classroom so you guys can see it. Here's a quick little peek at the answers if you guys need to pull out your phones, take a picture of this. It's really up to you. Again, I'll be posting this on Google Classroom so you can view this on your own time. All right. So starting off, welcome to week 2 of the higher tier review evening sessions. I'm happy that you guys are all here, so thanks for coming out. We are going to talk about quadratics today. So just kind of going over a few of the topics regarding quadratics, pretty much every single topic that's involved under quadratics, we're going to try to cover tonight. Maybe not necessarily super in depth, but just to give you a quick revision of those topics and kind of where you kind of fall depending on where you are in your practice right now. So the first few questions in the starter really are just at a grade 5 level, factorizing ax squared plus bx plus c when a is equal to 1, solving quadratic equations, and then drawing quadratic graphs. We'll get into that a little bit later on. Moving into the grade 7 topics are really just when you are factorizing those more difficult quadratics, along with using the quadratic formula. And then moving on to the grade 8 and 9 topics, we're looking at quadratic simultaneous equations, completing the square, and quadratic inequalities. Okay, so those are really more or less most of the topics covered under quadratics. So starting off, let's think about what it means to factorize. Okay, so we're going to start way back. We're going to kind of rewind to the basics here. So if you're kind of sitting at that grade 7, 8, 9 level, hopefully this will still be useful. But when we think of factorizing, really we can think of it as just breaking down numbers into 2 or more factors. Okay, so a quick example, we can think of the number 8. Our factors of 8 are going to be 1, 2, 4, and 8, because we can say that we have 1 times 8 and 2 times 4. These are all my factors of 8. All right. Moving on, we can move into more difficult or more complex terms, such as 4x squared. So our factors of 4x squared, well, we can have 1, 2, and 4. We can have an x in there as well as an x squared, because these are all factors of 4x squared. Now, when it comes to something such as, let's go with x squared plus 4x plus, let's go with 4. Okay, we can actually factorize this as x plus 2 times x plus 2. And we can think of these inside the brackets as factors. So this is a factor, and we can think of this really as a double factor. Probably should have picked a different example, but pretty much anything inside of these brackets here, we would consider them individual factors. Okay, so when we're factorizing, we're just breaking something down into a product of 2 or more factors. All right, so starting off with some really simple things before we actually start with factoring, I want to talk about solving equations, because solving equations I actually think is quite straightforward, and I'm going to actually rewind even a bit more than this. I want to talk about something called the zero product law or property. So zero product law or property. Excuse my writing today. I actually have an injury on my pinky, so I'm struggling to hold the pen properly. So when we think about the zero product law, really what it states is that if I have some factor a times b, and that's equal to 0, then one of 3 things is true. Number 1 is a must be equal to 0, because 0 times b is 0. Second thing is B has to be equal to 0 because A times 0 is equal to 0. Or number 3, A and B are both equal to 0. Okay, so if you understand that, solving a quadratic equation is actually pretty straightforward, okay, because we're thinking we have this factor times another factor is equal to 0. So coming back to solving some sort of equation, from our starter, we had solve p minus 10 times p plus 7 is equal to 0. So I'm actually going to give myself a little bit more room here. Oh, can't do that. I forgot. Made those immovable. So if we have p minus 10 and p plus 7 is equal to 0, essentially what I'm saying is, well, p minus 10 could be 0, but when is equal to 0? So from here, I would say that p minus 10 is equal to 0 when p is equal to positive 10. Okay, so if I substitute 10 into here, 10 minus 10, this whole thing becomes 0, and 0 times anything is 0. So our zero product law will hold true. So that is one solution. And our second solution comes from the p plus 7. So we have p plus 7 is equal to 0 when p is equal to a negative 7. Okay, so those two solutions, when I substitute them into their respective factors, or rather brackets here, will make this equation equal to 0, which is exactly what we're looking for. Now, again, that's not a very concrete thing. That's, it's very abstract. The idea of multiplying these two things together is pretty abstract. So we want to make meanings of this. Okay, when we multiply these two together and we make it equal to 0, let's take a look at this first. When we actually multiply those two together, I'm going to let's extend the page just a little bit. So if I were to multiply these out, p minus 10, p plus 7, we end up getting p squared, let's go minus 3p, and then minus 70. Okay. Now, if I were to graph this, and I come up with the equation y is equal to p squared minus 3p minus 70, what actually pops out is that shape called a parabola. It's that U shape that you guys will see when we're graphing a quadratic, okay? And I know that these two solutions that we found, so p is equal to 10 and p is equal to negative 7, so let's put positive 10 right here, and this isn't going to be to scale, but we'll put a negative 7 over here. These two are actually going to be my x-intercepts of that graph. Okay, so the important takeaway from this is that our solutions to an equation, or to a quadratic equation, are equal to the x-intercepts of the graph. Okay, so our solutions that we find here actually tell us where these x-intercepts are going to be. Okay, and that's going to be a really important property to remember. Now, the next thing that I want to talk about is, well, how do you know if that U-shaped parabola, so we know it's going to either look like this or it's going to look like this, how do we know if it's going to open upwards or if it's going to open downwards? Okay, so when I say open upwards, we're talking about this guy here on the left. And when we talk about it opening downwards, it's going to be this guy here on the right. We're going to go back to what we call the general form of a quadratic. So if we have ax squared plus bx plus c, we can see that we're just going to compare all the different values here. So if we were to compare the p squared and the x squared, we've got that there. We've got this p and the x. And now we're going to look at those coefficients. So in this case, we know that our a value, we don't see it. Our a value is going to be 1. Okay. We know that our b value here is going to be a negative 3. And from here, our c value is going to be a negative 70. Okay, so that's where we're taking those coefficients of a, b, and c from. Now, the key here is if you're trying to figure out if it opens up or down, okay, so if A is positive, then it opens up, and it's going to look like a U. And if A is negative, then it's going to open down. And it's you're gonna have to turn that frown upside down at some point. But that's really what we're looking for. Okay, so now because we know that a is equal to 1, then our parabola is going to open downwards. And this isn't a very good parabola, unfortunately. Maybe I'll read through that one again. So it's going to come down just like this. My hand's a little bit shaky. So it's going to look something like this. Okay, and maybe if I will, let's go ahead. Let's move this all down. And we can actually figure out what that y-intercept is going to be. In this case, if I plug in a 0 for p, so 0 squared minus 0 times p, so all of this will cancel out. And we can see that we're left with negative 70 as my y-intercept. Okay, so just really quickly, that's kind of understanding where a quadratic graph comes from, okay, and where the graph crosses your x-axis, coming up with those x-intercepts. Okay, so are you feeling okay with solving quadratic equations? Yeah, I get a thumbs up in the chat. You're feeling pretty good about it. Perfect. Okay, and now just because we are working, obviously at that higher tier, nothing really changes if we get something like this. So let's say we have let's go with 2x minus 3 and x plus 5 is equal to 0. It doesn't really change if we have a coefficient here. Really, we just say 2x minus 3 is equal to 0. We're going to move that 3 onto the right-hand side and then simply divide both sides by 2. Yes, you can have fractions as x-intercepts. X is just 1.5 in this case. So there's really no difference with something like this. Okay, so we're going to move on into the actual factorizing portion. Again, spending a lot of time just kind of giving you guys the background on this and hoping to wrap or put kind of a ribbon on the quadratics content so that you kind of get an in-depth understanding from top to bottom here. Okay, so we're going to move on. We're going to talk about factorizing itself. Maybe what I'll do is I'll actually get you guys to hold on a second for something like this. I'll talk about factorizing first. So when it comes to factorizing, typically what I do is I actually start with the harder quadratics, so meaning I start at the grade 7 level. And the reason why is I want to kind of tie it back to expanding brackets. Okay, so if I go to expanding brackets, let's rewind a little bit. Let's say, for example, I've got 2x plus 1 and x minus 3 here. One way that I'd be able to expand this bracket is by multiplying 2x with that x minus 3. Okay, so I can go 2x and x minus 3. And then after that, I can take this positive 1 and multiply it with x minus 3. So I'd have the plus 1 and the x minus 3, like so. And then I can simply expand my brackets, 1, 2. So this will give me 2x squared minus 6x. And then over here, plus 1x minus 3. So plus x and then minus 3. And there's going to be a really specific reason why I do this. Okay, I'm going to combine my two middle terms here. All right, and we'll end up getting a minus 5x in the middle. And my term at the front and my term at the in the last position there isn't going to change. Okay, so I'll end up with a simplified expression of 2x squared minus 5x minus 3. And this is what we call expanding brackets. Okay. Now, if we kind of split this up in the middle and we think, well, let's start off at the bottom, 2x squared minus 5x minus 3. And let's go ahead. This is expanding brackets. And now what we're going to do is just understand that factorizing is really just the reverse. Okay, it's the opposite of expanding brackets. We're going to kind of split these two back into these two brackets here in a way that we call factorizing. Okay, so kind of the mystery here is thinking backwards. What happens between this step and this step when we're working backwards. And we can see that if I were to draw arrows to here and here, and if I were to look very closely at the negative 6x plus x, well, if we brought those two together, it gives us the negative 5x. And if we were to split this negative 5x up, I could actually rewrite it as negative 6x plus x. So I'm going to do that. And again, don't worry too much about where I'm pulling those numbers from, but just hopefully you can see that I can actually rewrite it like this. So this negative 5x becomes negative 6x plus positive x. Nothing happens with that 2x squared or the minus 3. So you can see we're just kind of working backwards here, okay? And now I want to focus our attention to where we expanded previously, okay? But we're actually going to factorize now in this case. So we went from 4 terms here into these two grouped sections. Let me fix that a little bit. And what we're actually doing is we're just pairing these up. I'm going 1, 2, and I'm pulling out the greatest common factor, the GCF, from each pair. And we can see here that our GCF is going to be 2x, and I'll have x minus 3 here. And from these two, because there's no common factor other than 1, I'm just going to put a plus 1, and I end up with an x minus 3. The cool thing here is that I get x minus 3 and x minus 3 are going to be the same thing. So I can actually factor that out as my common factor. And all I'm left with is a 2x plus 1. Now, if you're really confused about why we're allowed to factor out that x minus 3, remember what I said about the terms inside a bracket. So we have what we call a binomial factor here, x minus 3. That is a common factor coming out of that 2x and that positive 1. If you don't quite see it, let's go ahead and compare. Let's actually do this. I'm going to say let x minus 3 be equal to y. Okay, so I'm going to rewrite this as 2x. And instead of putting x minus 3, I'm going to replace it with a y. So 2xy plus 1. And then instead of x minus 3, it's just going to be plus 1y. And we can actually factor out this y to the front. And what's left over? 2x plus 1. And if we go ahead and replace this y here with what we had originally, remember we said y is the same thing as x minus 3. This x minus 3 just gets popped back in front. Then we have 2x plus 1. Okay, so that's where that idea of understanding exactly what a factor is makes things a lot easier to factorize once we understand that we're really just multiplying two things together. Okay, so let's get down into, well, where do the negative 6x and the positive x come from? Okay, because right now it probably looks like I am pulling numbers out of thin air. And it's really not the case. For you guys who are sitting in year 11, you've probably been taught a number of ways to factorize. So if this doesn't make any sense to you, just sit tight for a few minutes. I don't expect you to suddenly switch, but I do think that this is a very consistent way of factorizing, okay? So we're going to look at this question here. So this is from the starter. If you are feeling like you want to just go ahead and start with some extra practice, I've got 6 questions here. Hopefully it's big enough for you guys to see. But with this question, we'll go ahead and start working through this one together. So anytime you guys are asked to factorize, typically we are going to look for the greatest common factor first. Again, could we factorize it like this? Sure. Are we going to have a good time? The answer is no, because the numbers are quite big. And we can see pretty quickly here that we can actually factor out a GCF of 3. So I'm going to rewrite this as 3. That's my GCF. And now I can rewrite this as 2x squared minus 15x plus 7. Okay, so now things are looking a little bit easier. And what I really need to work with is just this guy here. I can just ignore that 3 until later on. Okay, so we're going to look at this, and we're going to compare this to ax squared plus bx plus c. And we're going to find our three parameters here. So we can say that a is equal to 2, B is equal to a negative 15, and C is equal to a positive 7. Okay, so this is where I want people to be pretty consistent with what they write down, and these are typically the steps that I take. We want something times something has to be equal to A times C. Okay, and A times C in this case is going to be equal to 14. And these same two numbers that we want to find have to be equal to B, which in this case is negative 15. So I'm going to start off with my factor list of 14, which is pretty straightforward. I have 1 times 14, and I have 2 times 7. That's all we really have. But we'll notice that when I add the two numbers up, it's going to have to be negative. So the only way that I can get a positive 14 is by having two positive numbers or two negative numbers. So in this case, we're actually going to look at having these as both being negative. And we can see the only one that fulfills this condition of adding up to negative 15 is going to be negative 1 and negative 14. So negative 1, negative 14, does it multiply to 14? Yes. Negative 1 plus negative 14, does it multiply to give me negative 15? And the answer is yes. I actually like to go back and write this in myself, just to kind of check yourself, because again, the worst thing you can do is choosing the wrong combination numbers and having to restart later on. Okay, so let's go ahead and rewrite this 2x squared minus 15x plus 7. And these two numbers, remember from the previous page, it looked like I pulled numbers out of midair. Okay, this negative 6x plus x, that's what we've just done with this negative 1 and negative 14. Okay, so here what we're going to do is I will rewrite this as negative 1x, or just negative x, and then negative 14x, because remember what we're doing is we're breaking down or decomposing this negative 15x into those two terms. And these two, the first and the last terms, will stay the same. And then from here, I'm going to pair these two up. And then I'll pair these two up. And we're going to look for the greatest common factor from each pair of terms. So from the first pair, we can see that we're able to factorize an x. And we're left with a 2x minus 1. And from these two, I can factorize out a negative 7. So the key here is understanding that we have a negative here. We're just automatically going to put that negative here, so I can factorize out a negative 7. And you'll know if you've done it wrong because, and let's finish this off first, negative 7 times positive 2 gives me that negative 14 and negative 14x. And when I factorize a negative 7 out of a positive 7, I have a negative 1 or a minus 1 here. And remember the key was we want the same factor, okay, or same terms in this case inside both brackets, meaning that I'll have the same binomial factor, so the 2x minus 1. And that's exactly what I'm going to factorize out to the front. And what's left over is simply an x minus 7. And what we can do here is we can check your work by expanding your brackets and making sure that you get the same thing again. Now, before we actually finish off this question, you'll notice that we're missing this 3. So I'm actually going to bring it back down. Okay, so we've just kind of ignored that 3 from the beginning, and that's totally fine to do. So we're going to bring this 3 back down here, okay, to the front. And you'll know from working with transformations that this is just going to apply a vertical stretch to your function if we were to graph this as y is equal to 3 times 2x minus 1, x minus 7, okay? And it's not going to affect those x-intercepts or your solution to the equation, okay? So what we'll do is I will give you a few minutes to look at these 6 questions. If you haven't already started on them, please go ahead and do so. So up here on the top right, I'll keep this screen up so you guys can take a look at the questions. I do have the solutions on the next page. So I'll give you about 2 or 3 minutes just to work through some practice here. I'll zoom in a little bit because I think that's a little bit small. So I'll leave this for you guys here. Okay, so you can kind of see the starting point as well. Okay, so I'll put about, I'll give you guys about 3-4 minutes to work through those, and then we'll continue on. If you have any questions, please type them in the chat. I'll be more than happy to answer them. Are we doing all right so far? I know it's a lot of information. So these questions are just asking you to factorize. So can we break down each of these expressions into a form that looks like this? That's all we're trying to do here. So when we're being asked to factorize, we're trying to break them down into essentially two factors that multiply into each other. Not a problem. So maybe I'll go through maybe one more example with you guys. Again, if this isn't the way that you were taught to factorize by your previous teachers, and you don't like it, please don't feel obligated to use this, as again, this is just a different way of looking at things. Really, when it comes to factorizing, more or less, pretty much everything is decomposition. It all boils down to visually, what is it going to look like? And maybe if you guys are done with factorizing those questions, go ahead, type your answers into the chat just so I can kind of get a feel for how we're doing. Got p minus 1, 3p plus 5. Okay, so I would say, Oscar, have you checked your work? Have you expanded it again to see if you got the right middle term there? Not yet. So you actually have your signs mixed up. You should have a negative, so it should be 3p minus 5 and a p plus 1. Right, so that's been a few minutes now. I do want to kind of move on here. I know that these questions do take a while, so I will be posting the full worksheets for these on Google Classroom, so you can take a look at those later on. All answers will be provided, but I do want to run through a few of these, or at least maybe just one, so we can move on to the next portion here. Here are the answers. So if you want to quickly go ahead and take a look at these, I will zoom in just a little bit more so you can see the answers. So remember, we're factorizing, we're breaking down these polynomials, or rather this trinomial, into a product of two or more factors. So 3p minus 5 is a factor, p plus 1 is a factor, okay? And then maybe what I'll do is we'll look at perhaps question number 3 together really quickly, okay? So if I have 3n squared minus 8n plus 4, I want to pull out a few different things. I can see here that a is equal to 3, so a is equal to 3, b is equal to negative 8, and c is equal to positive 4. All right. I don't need to factor out a GCF, or I can't factor out a GCF. There's no GCF from this trinomial. So what's going to happen is that means we're looking for something times something has to equal to a times c, which in this case, 3 times 4 is 12. And something plus something has to equal to b, which in this case is equal to negative 8. Let's go ahead and list our factors of 12. 1 times 12, 2 times 6, and 3 times 4, all multiply to give me a positive 12. Now again, like in the previous example, we have a negative sum here, which means that we need to put negatives on both sets of factors here, because negatives, if we have two negatives, they multiply to give me a positive 12, but we need a negative sum here. So in this case, negative 2 and negative 6 are going to be the two numbers that we're going to select. So I'm going to go ahead, double check. Negative 2 times negative 6, does it give me positive 12? Yes. -2 plus -6, does it give me a -8? And yes, it does. Okay, so from here, what we're going to do is I'll zoom out a little bit. I'm going to keep this question for another time, maybe. If you have questions about this, feel free to ask myself or your other teachers at school. I don't think we'll have too much time to get through this, but really, for this type of question, ignore the y and the y squared. Treat it like one of these questions. And I don't remember what the answer was, but if you end up getting like 2x plus 3 and x plus 4, all you need to do is just put that y back in at the end. Because we see here, y times y is going to give you the y squared. And when you go 2x times 4y, we're going to end up with like 8xy. And then these two terms will multiply to give you 3xy. Now, obviously, I'm just making up numbers here, but that's really all you do. Just treat them like a regular polynomial and just put that extra variable in at the end of every second term there. Okay, so coming back to this question, 3n squared minus 8n plus 4. We're going to factorize this by splitting this up into -2n and minus 6n. This 3n squared stays the same, and this positive 4 stays the same. I factor out my greatest common factor of n here, and I'm left with 3n minus 2 inside the brackets. And then from here, again, because I have this negative, I'm just automatically putting a negative there. Factor out a -2, and what's left is a negative, rather, I factor out the -2, and then we're left with a 3n minus 2. And you can see that we get exactly the same thing in both brackets. So that comes out as my common factor, so 3n minus 2. And what's left over will be this n minus 2, which is exactly what we want. Okay, so hopefully we're feeling, at least refreshed when it comes to quadratics here, or at least factorizing quadratics. The only thing that we haven't really had a chance to go through yet is something such as a difference of two squares. I believe I should have an example a little bit later on, but maybe I'll just kind of quickly cover it here. Let's say we have x squared minus 25. We can actually use the same method here. We can treat it as x squared plus 0x minus 25. And you can just work it out like that. But really the shortcut for a difference of two squares is we can see that the square root of this first term, the square root of x squared, is just going to be x. So I'm just going to put an x inside both of my brackets that I'll set up. So 1 and 2. And we can see here that the square root of 25 is going to be 5. So I'll put a 5 here and here. And we simply just need to put a plus and a minus. And we have factorized the difference of two squares. So that's kind of the shortcut method of factorizing something like that. If you come across something that might be a little bit more difficult, let's say, for example, 9y squared minus 16z squared. Make it something that looks like this. We can just see that's really more or less the same thing. I'm going to set up my two sets of brackets here. I recognize that this is the difference of two squares because this is a perfect square or a square term, and this is also going to be a square term. So from here, the square root of 9y squared is simply 3y. So 3y and 3y go here and here. And then the square root of 16z squared is 4z. So 4z goes here and here. And once again, we just need a positive and a negative sign there, and we are set to go. Okay, so hopefully that gives you a quick little refresher on a difference of two squares. How are you feeling when it comes to factorizing quadratics? I know I spent a lot of time on this, but again, you need to understand what quadratics really mean before you can get into the more difficult stuff. You get a thumbs up in the chat if we're still doing all right. Perfect. Okay. So the quadratic formula, I'm not going to talk too much about. Again, this graphing stuff, I'm not going to. I'll get you guys to ask me later on, but I do want to try to move on through the content. The quadratic formula, again, this is exactly what you'll see in your formula sheet. You guys are lucky enough to have the formula provided to you. The key part of this is understanding that you always need to make sure that if you're solving some sort of quadratic equation, it has to equal to 0. That is the key here, okay? So coming to a question like this, we'll see that it's not equal to 0, so we need to make it equal to 0. Let's move this negative 10 over to the left-hand side. So I'm going to go plus 10 and plus 10 on the left-hand side. So this leaves me with 2m squared minus 7m plus 13 is equal to 0. So what you might end up doing is you might be thinking, well, how do I know if I need to use a quadratic formula or not? And really, at the end of the day, if you're in doubt, just use a quadratic formula. Just note that the quadratic formula gives you the solutions. Okay, so if I were to come back to this example here with the 3n minus 2n minus 2, if I were to use a quadratic formula on this guy here, this actually gives you the solution to this. So it would actually give you n is equal to 2/3, and n is equal to positive 2. And from here, you'd have to work backwards, right? So if I have n is equal to 2/3, I can multiply both sides by 3. I got 3n is equal to 2. And then I subtract 2 from both sides, and I get 3n minus 2 is equal to 0. And we can see here that 3n minus 2 is one of my factors. Okay, so if you're in doubt, use the quadratic formula, but you just need to kind of understand when do you need to use the quadratic formula. Okay, so coming to this question, well, how do we know? Let's go ahead. Let's see if we can factor this normally. So again, we're going to use that same method that I was talking about, the decomposition. We have a is equal to 2, b is equal to negative 7, and c is equal to 13. And we have something times something has to equal to a times c. So in this case, 2 times 13 is 26. And something plus something has to equal to b, which in this case is negative 7. So looking at my factors here, 26. So I've got 1 and 26, 2 and 13, and that's really all we've got. And we need to have a negative 7 when we add them up. So you can see here, having two positives isn't going to work. We're not going to add to negative 7. And also having two negatives is also not going to work. Okay, so we can quickly see here that we need to use the quadratic formula, okay, or at least attempt to use the quadratic formula to see if it actually gives us any solutions to this. Okay, so that's how you really more or less will know. And there's different ways as well of knowing if you should be using quadratic formula and how many factors you're going to end up getting, or how many x-intercepts of your graph you're going to end up getting. But we'll talk more about that at a different time, or ask me at school or ask a different teacher as well. So all we're going to do is we're going to identify your a, b, and c values. So we have a is equal to 2, b is equal to negative 7, c is equal to 13. Okay, and again, this is pulled out of ax squared plus bx plus c. All right, so we're going to substitute those values into our quadratic formula here. So I have x is equal to negative b. So let's be very, very careful. This is the number one mistake that I see students making all the time. So we're going to have negative b, so negative 7, plus or minus the square root of b squared. So I'm going to put negative 7 in brackets, squared, minus 4 times 2 times 13. And I'm dividing all of this by 2 times 2. And that gives me a positive 4. So negative 13 plus 10 is, oh, sorry. Thank you for pointing that out. Oh my goodness. Plus 3 or minus 3. That has been there for a while. My apologies. Let's go ahead, change that. I think I would have noticed at the very end if I went through and thought, this doesn't quite work out. Thank you for pointing that out. So we're going to have bonus points to you, Oscar, or sorry, Stan, for pointing that out. Appreciate it. So we're going to have c is equal to negative 3. So let's go ahead. Let's change that a little bit. Luckily, that doesn't affect us too much right now. We haven't gone too far yet. Okay, so now that we've made that correction there, let's go ahead and make some simplifications there. So negative 7 gives me a positive 7, and I'll have plus or minus the inside, negative 7 squared. So that's negative 7 times negative 7. That gives me a 49. And I'll have a negative 4 times 2 is negative 8. And negative 8 times negative 3 is plus 24. And I'm dividing all of this by 2 times 2, which is just a 4. X is equal to 7 plus or minus the square root of, that's going to be 63 divided by 4. Okay. Not 63, that's 73. Definitely need a coffee again pretty soon. 73 divided by 4. Okay. So this means that I have two answers. I have x is equal to 7 plus the square root of 73 divided by 4. And my second answer, which I'll have x is equal to 7 minus the square root of 73 divided by 4. Okay. So in a GCSE style question, they might say that your answer is going to be x is equal to a plus square root b divided by c. They might ask you for your values of A, B, and C. Okay, that's something that they might ask you. They could also ask what is A times B times C in this case, right? So again, you just have in this case, A is equal to 7, B is equal to 73, and C is equal to 4. So depending on the format of the question, you just need to make sure that you read it, you understand it carefully, but you'll at least be getting pretty close to full credit once you get to this stage here. Okay. You feeling okay about the quadratic formula? You get a thumbs up in the chat. We're doing all right. Okay, excellent. So I'll be posting up a worksheet with more questions where you can use the quadratic formula and use it exclusively, really, to just do some more practice. Again, because you got the formula, I'm not going to spend too much time on the quadratic formula. Maybe just a quick note, understanding that if we were to look at b squared minus 4ac, this is what we call the discriminant. Okay, just a quick little note here. B squared minus 4ac gives us the discriminant. And there's really three sections or three things that we need to know about the discriminant. Maybe what I'll do is I'll move this down here. So b squared minus 4ac is what we call the discriminant. And it tells us one of three things, okay? So if you have b squared minus 4ac is greater than 0, we're going to have b squared minus 4ac is equal to 0, and b squared minus 4ac is less than 0. Okay, so for each situation here, if your discriminant is greater than 0, then you have two real roots. Over here, if it's equal to 0, you're going to have one real root, or sometimes people call these two distinct real roots or one distinct real root. And then for the last one here, you'll have no real roots. So again, very abstract concept, but it's pretty straightforward once we give this kind of a visualization. So if your discriminant gives you two real roots, basically you're going to have a graph that could look like this. Remember, your roots are really just your x-intercepts that we're talking about. So we're going to have two that look like that. Could also look something like this. Again, it doesn't necessarily tell you the direction that your parabola is going to open, right? But just tells you that you're going to have two x-intercepts for your graph. If you have one real root, it's going to look something like this, where it just touches down at that one point on the x-intercept. And if there's no real roots, it just means that your parabola does not have any x-intercepts, and it's just going to be kind of floating there. So it could look something like this. Okay, so that's what your discriminant tells you. Okay, and hopefully that's kind of cleared up, or at least refresh your memory on what the discriminant does and what does it mean if something has real roots, two real roots, one real root, or no real roots. Okay. All right, so moving on. So I know officially we have 6 minutes left, but I do want to see how much of this I can squeeze in to maybe another half hour. Again, if you need to go at 8, please feel free to do so. Otherwise, I'm just going to keep going. All right, so let's move on to the next topic here. We're moving right into solving inequalities. Okay, so the reason why I'm going into inequalities right away is because it's actually a pretty straightforward idea once we understand how to factorize. And at this point, I want to point out that it's actually not very time efficient. If you solve questions like this or factorize polynomials like this using decomposition, okay? And we'll notice that the big difference between a question like this, x squared plus 4x plus 3, is different from all of these questions that we did earlier because our a value in this example is equal to 1. So we can actually factorize this pretty straightforward by seeing that, well, we need two numbers that multiply to 3 and add up to 4. Okay, so they multiply to 3 and add up to 4. So we only have two combinations. So the only one that works out in this case is going to be, oops, sorry, 2 times 2 doesn't multiply to 3. My goodness. We only have the one combination that works out for us. So it's going to be 1 and 3. Okay, and we can actually factorize this and say that we have x plus 1 and x plus 3 is greater than 0. Now, the reason why I've kind of left this towards the end and why it's a grade 8, 9 concept is, one, you need to understand how to factorize. Two, you need to understand what the graph is going to look like without using a graphing calculator. Okay, so from what we've talked about before, each of these factors tells us what our x-intercepts are going to be. Okay, so if it helps you out, we can think of this as being x plus 1 times x plus 3 is equal to 0. So you can make it equal to 0 if you want. We can just leave it. Doesn't really matter. And what we're going to do is we can see here that if I were to set these equal to 0, I would get x is equal to negative 1. And over here, x plus 3 is equal to 0 when x is equal to negative 3. And because my a value here, we can see that this would be 1x squared. So a is positive, a is greater than 0, so it opens up. And again, it doesn't really affect us in this case, but because we're drawing a quick little sketch here, it's nice to have that visualization. So we'll have one x-intercept at negative 1, and we'll have one here at negative 3. It's going to look something like this. And we know it's going to open upwards. If I want to put that x-intercept, or rather y-intercept here, 0 squared plus 0x, or 4 times 0 rather, that's 0 plus 0 plus 3. I'm going to have my intercept there of positive 3. Again, not really necessary for this question. We'll go ahead and do something like that. And then we're asking ourselves, okay, this is saying, when is it positive? When will this graph be positive? When will it be above that x-axis? Okay, so pretty much everything above here is positive, and everything below here is going to be negative. So we're going to split it up into two sections. So I'm going to highlight. So you have all of your positive section over here compared to all of your negative section down here. Okay, so when is it going to be positive? And we need to see, or we need to understand why we're using this sign versus this sign. Okay, now in this case, we're using this sign here on the left, okay, just greater than, because we are not included. So this is not inclusive versus this being inclusive. Okay, so what that means for us in terms of our answers, we can say that x, in this case, we're going to look at when is it positive. So we can say that x has to be less than negative 3. So if we're looking at this portion here, x has to be less than negative 3. Can it be equal to negative 3? The answer is no, because we want it to be greater than 0. If it was equal to negative 3, it would be 0, and that's not what we're looking for. Okay, so that's one answer. And your second answer is, if we're looking coming along this way here towards the right, we can say that x has to be greater than negative 1. So x is greater than negative 1. And these two combined will give me that solution for this inequality. Okay, so hopefully that makes sense there. Do we have any questions about inequalities? Maybe I'll give you a few minutes to work through these examples here on the right-hand side. So you can go ahead, take a quick little peek here. I'm going to post a link to the answers, or rather a file with the answers in Google Classroom. So you can go ahead and take a look there as well. So maybe take a couple minutes, understand that you need to factorize first before you can actually solve these. And then maybe we'll take a look at one together. And then I want to take a look at completing the square and quadratic simultaneous equations for the last little bit here. So again, I know we officially end at 8. If you need to head out, please don't feel bad about doing so. I'm going to post the entire recording up on Google Classroom so you can take a peek afterwards. How do you get the y in the graph? So again, right now we're not too worried about getting the y in the graph. We're kind of just taking a look at this, right? And if you want to, you can think of it as y is equal to x squared plus 4x plus 3. And we're really just seeing when is your graph positive and when is it going to be negative. So when we think of it being positive, are your y values positive or are your y values negative? That's kind of what we're doing here with the yellow and the blue. Does that kind of answer your question? Okay, so I'll give you guys another minute or two here to maybe take a look at a couple of questions. When you're factoring or when you're factorizing, you keep switching up the symbols with the correct numbers. How can you fix that? Okay, so excellent question. So what I'll do is maybe I'll take a look at the first couple here. So let's do this x squared minus x minus 20 is less than 0, okay? So x squared minus x minus 20 is less than 0. Okay, so we know that because we're factoring or factorizing a simple trinomial here. We know we're just looking for two numbers, so something times something has to equal to negative 20, and something plus something has to equal to negative x, or negative 1 rather in this case. So something plus something has to equal to negative 1. So the way that I want to make sure that we get the right symbols, okay, whether it's the or right signs rather, whether it's positive or negative, is I always keep this same exact setup every single time. Okay, you want to make sure that you identify your values correctly. That's a negative 1 and a negative 20. That's one thing. Second is I like to make sure I list every single factor pair. Okay, so with 20, I'm just going to ignore the negative for now. 1 times 20, 2 times 10, 4 times 5. Okay, so I have those three combinations. And because I know that it's going to be a negative 20, one of these has to be negative. And since my sum is negative, then I know that my larger number has to be negative because that's the only way I can get a negative result. And that means I'm going to have 4 and negative 5 in this case. All right, so if I'm able to kind of stick to the same routine, the same process every single time, okay, with the factorizing, then I'll be able to make sure that it's always consistent. Okay, and there's nothing that I'm really changing. So once I get to this point, I can just go ahead, take those numbers, and put them in as is. So I'll have x plus 4 and x minus 5. Okay, are going to be my two factors. Now, because we're saying when it's going to be less than 0, okay, we want to kind of look at this on the side, x plus 4, x minus 5. Let's say we make that equal to 0. Okay, so I can just do that on the side here. So hopefully I answered your question about how do you get the right signs when factorizing. Did I answer your question? I hope I didn't kind of... Perfect. Okay, so from here, we know that we're going to have x plus 4 is equal to 0. So meaning that I have x is equal to negative 4. And then over on the right-hand side, x minus 5 is equal to 0. x is equal to positive 5. So that's my second intercept. So we can see that from our expression here, that a is positive. So that means that my parabola is going to open upwards. So it's going to look something like this. Again, not really relevant in this case, but relevant later on. So we're going to have negative 4, probably somewhere over here, and a positive 5 somewhere over here. We're going to have an x or a y-intercept of negative 20. So it's going to be quite far down. Again, doesn't really matter what that looks like, but we'll get something like this. So in this particular problem, we're looking to see when is it going to be negative? When will our y values be less than 0? Okay, so when will this happen? When is it negative? Well, it's going to be negative basically for anything underneath here. And when is it going to be negative? What values of x, okay, will make this graph negative? So let's go ahead and let's look back at our numbers. So we have negative 4 and positive 5. Okay, so our values of y, okay, our function here, they will be negative when it's between negative 4 and positive 5. Okay, so to write that as our answer, x has to be greater than negative 4. So it covers everything, all your x values towards the right. Okay, again, I know it's confusing because we're saying when will our y values be negative? Okay, our y values will be negative when our x values are greater than negative 4. But at the same time, your x values also have to be less than positive 5. Okay, so if I were to pick something random here, let's say x is equal to 1, well, is my graph negative at this point? Yes, it is. Let's check something else. Let's go with x is equal to negative 3.105. Is my graph negative at this point? Yes, it is. Okay, so as long as it fits within that solution set, then we've solved this inequality. That's what we're looking for. Okay. Now let's see how this or how our answer would change if, for example, it was less than or equal to 0. So let's go ahead and let's put this inequality sign. Let's change up that inequality sign here. The only thing that would change is we would have our values be inclusive, our end values be inclusive. So you would just simply do this and this if it was less than or equal to as well. All right. So hopefully that makes sense, and that that I've spent a decent amount of time on inequalities. Are we feeling up to par for inequalities? Shall I do another example? Or are we good to move on? Got one thumbs up. One out of, I think we've got, how many people are in here still? 1, 2, 3. Not a lot. There's 2 of you left. So again, you guys are getting like almost 1-to-1 tuition. Okay, let's go ahead and move on then. If you guys want, you can take a picture of these extra problems to try. Again, I'll be posting these on the Google Classroom, so you can take a look later on as well. Okay, maybe the last thing that I want to mention before I move on from inequalities is this one problem here. The trick for this one is you'll notice that it's not greater than 0. It's greater than 8x plus 9. Really all we need to do is move everything to the left-hand side. We'll have x squared minus 8x minus 9 is greater than 0. And then we can just solve it exactly the same way as our other questions. Okay, let's move on to completing the square. So completing the square, it's quite fun. Again, I'm not saying that as a math teacher. I'm saying that because I do find it quite fun. And the applications of completing the square are pretty useful. Again, less useful now because there are such things as graphing calculators. But again, just something nice to know. So this is really the formatting of what our starter question kind of looked like, finding the turning point of x squared minus 6x plus 1. all we need to do in this case, let's go ahead and let's rewrite this, x squared minus 6x plus 1. So all we need to do to complete the square is we're going to take half of our middle term's coefficient. So half of -6 is -3. And we're going to square it, and then we add it to the expression. So we're going to have x squared minus 6x. I'm going to add 9, so plus 9. But because we can't change the mathematical value of x squared minus 6x plus 1, I also have to subtract 9 at the same time. Okay, because you can see here, these two would cancel out. We're not really changing anything. So we're allowed to do that. And again, I wish I had more time to talk about what completing the square looks like visually, but it literally does look like you're making a square out of something that's not a square, okay? And then we just have the plus 1. And all we're going to do is we're going to split this up so that we have our perfect square trinomial here. And we can factor this pretty quickly by asking ourselves what multiplies to 9 and adds up to give us -6. Well, we're going to have x minus 3 times x minus 3. And that's really what we're looking for. -9 plus 1 gives me a -8. And then I can simplify this a little bit. I can rewrite this as x minus 3 squared. And then we'll get -8. Okay? So that means we've completed the square. And we've been able to get it into this format here, x plus a squared plus b. So we can see here in this case, a is -3 and b is equal to -8, okay? So let's go ahead and write down the actual coordinates. So our actual coordinates in this case of our turning point come from our two numbers that we've just found. And again, the way that the question is written here, I'm actually not a fan of it being written as x plus a squared plus b. I think the standard form, depending on the textbook you use, you might get something like x minus h squared plus k, and we get hk is your turning point. Okay, so from that, we'd actually get our turning point is going to be a +3 and a -8 in this case. All right, so that's how you end up with your turning point by completing the square. Okay, so how did I choose the 9? So what's happening here is we are taking -6 and we're dividing it in half, which gives us -3. And then we take that -3 and we square it to give us the 9. And that's where that 9 comes from. So I know that seems really, really arbitrary for me to kind of just go through it. I wish I had time to do just a proper lesson on completing the square. I can probably send you guys links to videos of it being kind of visualized. But the short and sweet version is we're taking half of this middle term. Okay, so half of whatever the coefficient is, and then we're squaring it, we're adding it, and we're also subtracting it at the same time. So maybe what I'll do is I'll do a couple more examples with you to help you feel a bit more comfortable with that. All right. So let's do these two here on the side and see how we feel. Again, I know completing the square, it seems very, very arbitrary right now. It's just kind of, it feels like even for me as a teacher, it feels like I'm just kind of pulling numbers out of midair. But again, with the short amount of time, don't have too much time to go into heavy in-depth detail. Again, feel free to ask myself or any of your other maths teachers to give you a more in-depth answer at school. But again, this is just kind of teaching the skill right now with completing the square. So let's maybe take a look at this example. We have x squared plus 10x plus 2. So again, this is where we're going to choose, what seems like that arbitrary number. I'm going to take that middle term's coefficient, so that 10x, the coefficient is 10. So I'm going to take the 10 divided by 2, which gives us 5. And I'm going to take this 5 and I'm going to square it, which gives me 25. And then I will add it and then I'll subtract it. So I have x squared plus 10x plus 25 minus 25. And then we're going to keep the 2 there. Okay. And maybe what we should do is I'm going to introduce just writing the brackets down like this. Okay. Again, not necessary when your coefficient is a 1. And maybe I'll do an example later on where you can kind of see why we need to keep those brackets there. Okay. So from here, we're going to write it like so. And then we can factorize this x squared plus 10x plus 25. So the goal here is to come up with a perfect square trinomial, okay, that I can factorize now as x plus 5 times x plus 5. So we're choosing the number very, very strategically so that we're able to factorize it and have it look like this, okay? So then I'll have minus 23 on the outside, and I'll have x plus 5 squared minus 23. So from here, we end up, again, with our coordinates of our turning point. It's going to be a negative 5 in this case, and a negative 23. Are you feeling okay about that one? Do you guys want to try out this second example on your own, or the second problem, see if we can find the correct turning point? So give that one a try. I'm going to give you guys a more difficult problem where you can see why I would keep the brackets there. So 1, negative 2, can we confirm that that's our answer? Maybe I'll just do it really quickly here underneath. So we're going to take half of that middle term. So that's negative 1 squared. Oops. We're going to go minus 2x. We're going to go plus 1 minus 1. So again, let's go ahead and put the brackets up like so. We're going to keep that plus 1 inside. Bring out that negative 1 from the brackets. This is going to be factorized as x minus 1 squared. And then we still had, oops, the other minus 1 there. So actually this should be minus 1 in red. And we'll end up getting minus 2. So we end up with a turning point of positive 1 and negative 2. Perfect. Are you feeling okay about completing the square when it's a question like that? Excellent. So I want to take a look at a more difficult question. My internet was kind of acting up here, so it took me a while to find an example. Let's take a look at something like, let's see here. Let's go with, let's see. Let's do a question such as, let me make some room here. Let's go with, let's do this one. Y is equal to, oh, that's going to be a little bit too hard. I mean, yeah, that one could work. Sorry, I'm trying to find one that's reasonably difficult, but not to the point where you're just going to be really sad and feel like you don't understand what's happening. All right, let's take a look at this one. Okay, so let's go with y is equal to, I zoomed in very far. Let's go with y is equal to negative, or rather 5x squared minus 40x plus 76. Okay, so this is going to feel like it's a bit of a daunting task. But what we're going to do is we're just going to ignore that y equals. We're just going to kind of focus on our 5x squared minus 40x plus 76. And I'm just going to put brackets around this. Okay. So let's go ahead. I'm going to factorize. Okay, I'm going to factorize by doing this. We'll notice that your GCF, okay, is a 5, okay, between that 5x squared and the negative 40x. So I'm going to keep the x's in there, okay? Don't write 5x. I'm just going to have a 5 on the outside. And what that does is it frees me up to look at it like this. So I'll have x squared minus 8x. I'm still working inside the brackets there. And then plus 76. Okay, so a question like this is going to be a little bit more difficult, okay, because of that 5 on the outside now. Okay, and this is what would bring completing the square from a grade 8 question into more of a grade 9 question, because this is the one thing that changes. Okay, so this 5 stays there, nothing to it really. We're going to take half of that negative 8. So negative 8 divided by 2 gives me negative 4. And we're going to take that negative 4 and we're going to square it, and that gives me 16. Okay, so we're going to add 16, and we're going to minus 16, all inside the bracket. And then we're going to go plus 76. Okay, so are we happy with what I've done there? Are we following along? Makes sense why we have that bracket. Okay, now what's going to happen is you'll notice, okay, because that 5's on the outside, what's going to happen if I decide to expand this 5 to everything here? What would happen? Well, it just means that I multiply that 5 with that negative 16. Okay, so when I multiply that 5 with that negative 16, okay, and I'll do that in a second here, I'll have 5 of x squared minus 8x plus 16. And I'll just kind of worry about this portion for now, okay? So I'll just kind of run through this first. This would give me x minus 4 times x minus 4, and hopefully that part makes sense. 5, and then x minus 4 squared. Okay, so what happened to this negative 16? Well, if I want to take that negative 16 out, I have to multiply it with the positive 5 first. So this actually comes out as negative 80. Okay, when I take it outside of the brackets. Okay, so do you guys see why those brackets are really important, especially when we have that GCF of 5? Because before, what was our GCF if I factored something out? It was just 1, right? So if it's just 1, I'm multiplying by 1 when I take it outside of the brackets. Okay, so that's the main difference here in this case. So I have the minus 80 plus 76, and that gives me a minus 4, or yeah, minus 4 in this case. Okay, so if I just put that y equals back on, this means that I get a turning point at 4, negative 4. How are you feeling about this question? A little bit more difficult. Not the most difficult completing the square question I could ask you. There are ones including fractions, and yes, you're able to do it including fractions. You just need to make sure that you factor out that that GCF. Okay, awesome. Last little bit. So we're approaching 8:30. Again, thanks for sticking around for so long. It's nice to have an audience for maths this late into the evening. But the last topic that I want to touch on before we call it an evening is the idea of quadratic simultaneous equations. Okay, so simultaneous equations, basically you're looking for the intersection of whatever. Okay, you're gonna have two curves. You could have one intersection. You can have two, depending on what types of equations you're looking at. You can have multiple, but we're looking at these two in particular. So we're going to have a linear function down here. We're gonna have a straight line, and we're also gonna have a circle. Okay, so we could potentially have up to two solutions. Is really what we're looking at here. So x squared plus y squared is equal to 27. So we're going to go ahead and kind of think about how we want to solve this simultaneous equation. Now, there are two main methods to solving simultaneous equations. The first one being substitution, second one being elimination. When it comes to quadratic simultaneous equations, generally you want to be substituting because if you're trying to subtract, you need to somehow find a way to square a term, and that just makes things really, really messy. I wouldn't recommend it. I'm just going to go ahead and work with substitution. We're going to look at that second equation here. So if I were to label these, I would label this equation 1 and equation number 2. And we're going to change this up. I'm going to make y the subject, okay? And we're going to do that by just moving y onto the other side, so 3 plus y. And then I'm going to subtract 3 from both sides. So 2x minus 3 is equal to y, okay? And maybe I'll do that in red. So 2x minus 3 is equal to y, and I'll call this equation number 3. And what we're going to do is we're going to substitute this y back into equation number 1, okay? So we can't substitute it back into itself. It would just kind of defeat the purpose of why we made it the subject in the first place. So we're going to substitute into equation number 1, and what that's going to look like is we'll have x squared plus, instead of y squared, we know that y squared, or y rather, is just 2x minus 3. And we're going to square that, and that's equal to 27. So let's go ahead and expand this. X squared plus 2x minus 3 times 2x minus 3, that's equal to 27. And when we expand those brackets, we'll get x squared plus 4x squared. We'll get minus 6x minus 6x plus 9 is equal to 27. So I'll give you guys a second there to catch up. And then we're going to simplify. So we'll get x squared plus 4x squared gives me 5x squared. We'll have minus 12x plus 9 is equal to 27. And because we're looking at a quadratic equation, we want to set this equal to 0, okay? So let's get rid of that 27 from the right-hand side. Let's subtract that from both sides. We'll get 5x squared minus 12x minus 18 is equal to 0, okay? From here, you can't factorize anything. You can't factor out a GCF, rather, is what I should say. Feeling kind of lazy, so we're going to use a quadratic formula. Okay, so we get a is equal to 5, b is equal to negative 12, and c is equal to negative 18. So let's go ahead and write that down. A is 5, b is negative 12, c is equal to negative 18. If you tried to factorize this by hand instead of using quadratic formula, you're going to find that it's impossible. You're not going to be able to find anything that works out. So quadratic formula is really the only way that you can do it right now. You can also do this on your calculator as well. If your teacher's shown you how to do it, again, it's faster that way. But I'm just going to do this the old-fashioned way. So we'll end up with x is equal to negative 12. So negative 12 plus or minus the square root of negative 12 squared minus 4 times 5 times negative 18. And that's all divided by 2 times 5. Okay, so I'll give you a second there to catch up. So we can simplify this a little bit. We'll get 12 plus or minus 144. What's that going to equal to? Negative. That's going to be plus 360, I believe. Negative 20 times negative 80 is divided by 10. And I'm just going to skip ahead to our answers. We'll end up getting x is equal to, I believe it should be 3.44, or x is equal to negative 1.04, and this is to 3 significant figures. Okay. Are you feeling okay with that? Now, to get the most out of your answer, okay, you want to make sure that for the second portion, when you're substituting your answers back in, don't use the 3.44 that you've already rounded. Okay, what you've actually should do, okay, is you're going to look at, let's go to this second equation, 2x minus y is equal to 3. We know that to find out what y is equal to, okay, we could substitute it back into this equation. 2x minus 3 is equal to y. So 2 times whatever the answer was on your calculator. And we said, I think it was minus 3. 2x minus 3 is equal to y. And we end up getting y is equal to, what will our answer be? It ends up being about 3.89 to 3 significant figures for this one. And over here, we get 2 times your answer from the second portion, minus 3, is equal to y, and we get y is equal to negative 5.09. Okay, so if you're a little confused about what I mean by answer, okay, remember that when we plug this into our calculator, we'll get x is equal to 12 plus the square root of 144 plus 360. That ends up giving us, oh my goodness, 504. 504 divided by 10. And we'll also get x is equal to 12 minus the square root of 504 divided by 10. So when I say answer, I mean the answer from this guy goes here, and the answer from this guy goes in here. Okay, so we can wrap it up nicely. We can say that our solution, or our coordinates, are just going to be 3.44, 3.89, and negative 1.04, negative 5.09. Again, that's depending on what the question itself is asking for. It might just be happy with you stating x, y. Sometimes it asks for a coordinate. But really, I would say that most quadratic simultaneous equations are going to look just like this. There's not going to be much more to it. Typically, they're going to be worth, I would probably say, 5-6 marks, depending on the difficulty of the question. But yeah, how are you feeling? It is a lot of information, but I hope that's given you guys a good overview of pretty much everything, or at least most of the things to do with quadratics at the GCSE level. I know there's a couple other things that are quadratic related, like quadratic sequences, but again, this has already taken a solid hour and a half. Pretty happy with covering all this in an hour and a half. You are very welcome. So again, if you guys have any questions, feel free to ask myself at school or see any of your other math teachers. But yeah, thanks again so much for joining me. I'll post this recording up on Google Classroom. And yeah, take care. Have a good night. We'll see you guys next week.